Managing a wireless network with hundreds of access points sounds like a nightmare, right? What if I told you there's a way to simplify it all without sacrificing control or performance? In this video, I'll show you the power of autonomous APs and cloud-based architectures like Cisco Meraki. Discover how to automate configurations, monitor performance, and scale your network effortlessly. Whether you're an IT pro or just curious about networking, this video will change the way you think about wireless management. Ready to simplify your network? Let's dive in. The main function of an access point is to connect the wireless data of the Wi-Fi to a wired network in Ethernet. It is the AP that accepts connections from wireless clients so that they can become a member of the LAN as if they were using a wired connection. The access point is equipped with wired and wireless hardware to allow wireless clients to be associated with the wired network. The APs offer one or more sets of basic services, which is what is found under the initials of BSS, Basic Service Set. APs can also be seen as an extension of a dial-up network, which allows to connect SSIDs, Service Set Identifier, to VLANs, virtual LANs, at the access layer. In the diagram, we can see a network architecture with access points. So even if there are only 4 access points, a company can have hundreds or even thousands. In the example, we can see that the APs contain 2 SSIDs, the WLAN 100 and the WLAN 200. They were named in this way for match the VLAN number layers in Ethernet. On the diagram, we can see trunk links between the different layers to make the VLANs circulate well from one layer to another. On this architecture, standalone APs provide a fast path so that data can travel between wireless and wired networks. 2 wireless users who are associated with the same standalone access point can communicate directly this time without having to go through the wired network. This is where the term autonome comes from. As can be seen in the diagram, an access point must be configured with the IP management, which allows the box to be managed remotely. This allows you to configure SSIDs, VLANs, as well as radio frequency parameters, such as channel and bit rate. As with SWIFTs, these management addresses should not be part of the VLANs that circulate data. That's why on the schema, we use a dedicated management VLAN, which is VLAN 10. All access points must be configured and maintained individually, unless you use a management platform such as Cisco Prime or Cisco DNA, which is much more evolving. Because without this type of infrastructure, the configuration and efficiency of the network can become problematic in the event of an evolution. That is, as the wireless network grows, the infrastructure becomes more difficult to set up and also less efficient. Now we're going to look at a cloud-based Wi-Fi architecture. We have seen that a standalone AP needs a minimum of configuration and management, and that to manage them, we could use an in-house centralized infrastructure like Cisco Prime. There is an even simpler approach, which is a cloud-based AP architecture. In this configuration, AP management takes place outside the company, that is to say, in the Internet cloud. This is the case for Cisco Meraki, which offers centralized management of wireless, switched, and even security networks. Cisco Meraki is a complete solution for managing the network in the cloud. This brings a lot of simplicity to enterprise networks, as it allows network administrators to have better visibility as well as better control without the complexity of traditional architectures. For example, via the cloud networking, you can configure and manage access points, monitor wireless performance and activity, generate reports, and many other possibilities. Cisco Meraki access points can be deployed automatically as soon as you have registered with the Meraki cloud. Each APs will contact the cloud as soon as it is powered on and configure itself automatically. And it is of course possible to manage the AP directly through the Meraki Cloud dashboard. On the diagram that illustrates a cloud-based architecture, we can see that the network is organized identically to the one with the standalone APs. That's because even with cloud management, the access points are also self-contained. The most visible difference is the one represented by the small lines, indicating that all access points are centrally managed, controlled, and monitored from the cloud. The Cisco Meraki cloud also adds intelligence, as it is able to automatically tell each access point which channel and throughput to use. Data that is going to and from wireless clients also doesn't need to go back and forth in the cloud because it has a data plane built in. Data that is going to and from wireless clients also doesn't need to go back and forth in the cloud because it has a data plane built in. One for data traffic, and the other for management traffic, which consists of two functions. We have a control plane. This is the traffic used to control, configure, manage, and monitor the AP itself. And a data plane, which is the end-user traffic going through the AP. This distinction, or division, becomes very important as the network evolves.